All right, this is Unit 2 video notes, and we're going to start at Lesson 11. You're going to follow along and complete the notes, and you're going to do it as an ed puzzle, so there will be places to stop and you to figure out your answers. A table is a great way to organize information. Each horizontal set of entries is called a row, and the vertical set is the column. Table shows 2 columns and 5 rows. You can see these down here. It's a good way to represent equivalent ratios. Here's our double number line, also has our labels, and the price is $2 for 3 mangoes. We can see that here on the double number line, and we can see that here in our table. So our table shows rows and columns, and the first row or column usually tells you what this ratio is about. That's your labels. What's the advantage of using a table over other kinds or other methods? Tables you can use in any order. And it's easier sometimes for really large numbers or really small numbers. All right, here's some practice problems from lesson 11. Olive trees in an orchard produce 3,000 olives a year. It takes 20 pounds of olives to make 3 liters of olive oil. So this is our original ratio. How many liters of olive oil can this orchard produce in a year? If you get stuck, consider using the table. So I'm going to go ahead and pause right here and try to complete this problem. There's a couple ways you can attack this problem. One is we could find out how much olive oil for 10. We could find out how much for 100. I might go to 100 just because I know that 5 20s make 100. So 5 3s would make 15. And then how easy is it to get from 100 to 1,000? Well, that's times 10, which I would do times 10 on this side. And then how many 1,000s are in 3,000? So multiplying by 3. You can use your calculator. I know that 15 times 3 is 45, so it should be a 0. 150 times 3, 450. It's kind of dark. If I wanted to go backwards to 20 to 10, that is finding half of 20 is 10. So I would be finding half of 3. To find half of a number, oops, spelled that wrong, you divide by 2. So in a calculator, it would look like 3 divided by 2, and that equals 1.5. All right, let's go to the next page. In lesson 12, we learned how to find that 1, which we call the unit rate. And that is where one of our numbers is compared to 1. It's easier to multiply and divide. If our ratio is 4 pounds of granola for $5, what would be the price of 62 pounds of granola? So we're looking for the price. This shows two different ways. This table, the person decided to double, 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 many, many times. And then they decided, well, I need to take away 2 pounds and 2 pounds. And they figured out that half of 4 is 2 and half of 5 is 2.5. So they figured out that 2 pounds is $2.50. Or this person decided to go straight for the 1, which is that unit rate. 1/4 of 4 is 1, which means divide by 4. So 5 divided by 4, right? We think of 1/4 of 5 is the same as 5 divided by 4 because we know that fraction means division. So on your calculator, it would look like this. And then once we know 1, if I want to make it to 62, that's very simple. You multiply by 62, and then I take $1.25 times by the 62. So remember, when you are dividing by a whole number, for example, if we wanted to divide by 4, it is the same as multiplying by the unit fraction, which is that 1/4. All right. And they're giving you the same example. Divide by 4, multiply by 1/4. So you're going to do these problems. If 4 pizzas uses 10 ounces of cheese, how much per pizza? Remember, per means 1, so you're needing to find out how much cheese for 1 pizza and how much cheese for 15 pizzas. And then work on that for a minute. Okay, we're going to continue on our study notes. Lesson 13, summary. On the double number line, I think I need to turn my light on. Maybe that'll help. Okay. We put labels on the front of each line to tell what the numbers represent. On the table, we put the labels at the top of each column, telling what the numbers represent. There are two different ways we can represent a situation. A snail is moving at a constant speed down a sidewalk, traveling blank centimeters per minute. We see that right here, 6 centimeters per minute. We also see that right here. That is our unit rate comparing to 1. Both the double number line and the table help us to use multiplication to make equivalent ratios. But there is an important difference. Get the mouse out of here. On the double number line, the numbers are always listed in order. With the table, you can write the ratios in any order. And you can have skips, you can have gaps, you can skip numbers. For this reason, sometimes a table is easier to use. For example, if we wanted to know the snail in 10 minutes, if we look up here at our double number line, that's going to go way off our paper. We don't have enough room for that. We'd have to start a new double number line. But on the table, it's really easy. You can just draw one more thing. They already did their 10. It's simple. If I wanted 20, I could just add it. All right, practice problems. The double number line below. I'm not going to read it to you. Well, I guess I can. How much lemonade powder for different amounts of lemonade? So we have water and lemonade. And this would be our one batch. And they want you to make a table showing the same information. So we always have to have labels and your lemonade. And then you're just going to make it look the same information. 2 to 1.5, 4, 6, fill in the rest of the information. For number 3, Claire is going at a constant speed as shown on the double number line. At this rate, how far does she travel in each time frame? So you could use your double number line. You could also make a table. For that 1 hour, I'm going to have to go right here. And then I need to think, how do I turn a 2 into a 1? I have to do the same thing to 72. Once I know that, so for example, I'm going to do 72 divided by 2, and I'm going to find out that answer is 36. I should have done it on my calculator for you. 72 divided by 2 is 36. Once you know the 1, to find 3 hours, you would do 36 times 3. To do 6.5 hours, you would do that also times 36. Okay? I'm going to let you finish that. All right, lesson 14. When we have something happening at the same rate. First, we need our two pieces of information, which are help us to write a ratio. That describes the situation. We also need that third piece of information. They give us one number to help us find the other number. So let's look at this example. My recipe is 5 cups of cranberry juice, 2 cups of soda water. So our ratio is 5 to 2. What if I want 2.5 cups of cranberry juice per 1 cup of soda water? So there's our unit rate. We still need to know something about the size of the large batch. If we use 16 cups of soda number, what number goes with the 16? And we need to think, well, how did they get that? So you could think to yourself, well, 1 times 16, and grab your calculator, 2.5 times 16. That gives us 40. Most of us would probably recognize this relationship. 5 times 8 is 40. 2 times 8 is 16. You're always looking for the relationship between your ratios. Let's see. 8 jumps, 10 seconds. How many jumps in 45 seconds? So jumps and seconds. I want you to complete this table. I'm going to a 5 because it's a friendly number. So half of 10 is 5. Half of 8 is 4. And I chose 5 because I know I can get from 5 to 45. 10 to 45, not as easy. 5 times what is 45? If you're not sure, you do the opposite. So let's say I don't know what that mystery number is. I don't remember my math facts. So to find that missing number, I would do 45 divided by 5, and that's going to give me that missing factor. You can use that on any of the problems. So now I know it's 5 times 5. I do the same thing to the other part of the ratio. So 4 times 5 is 36. So 36 jumps in 45 seconds. All right, practice problems. The chef is making pickles. He needs 15 gallons of vinegar, but stores sell 2 gallons of vinegar for $3. Decide whether each of these ratios correctly represent the price of vinegar. So let's make a table. Vinegar and gallons. And my ratio is 2 to 3. And then I'm going to put on all the numbers that they're giving me. I got 4 gallons. Oh, it's not vinegar to gallons. I'm sorry. This vinegar is my gallons. This is my money. Always good to go back and check your problem. So then I need 4 gallons. I need 1 gallon. I need 30 gallons. I need $2 and I need $1. So let's just see how this works. All right, so if I double my vinegar to 4, I would double my money to 6. If I want to go, I don't know how this will show up. If I want to go from a 2 to a 1, that's a half. So half of 3. I'll do this right here, right? 3. Check my writing, I wrote it wrong. 3 times 1/2 is 3 over 2. I could leave it as a fraction, or I could write it as a decimal. 3 over 2, and I'm going to say or, and that's when I'm going to grab my calculator. 3 divided by 2 equals $1.50. How do I turn a 1 into a 30? I could do that. Or a 2 into a 30. I think I'm going to do a 2, because 3 times... Oh, I'll do that. We've had a lot of practice the last couple days. 2 times 15 is 30. So 3 times 15. If you don't know, grab your calculator. 3 times 15 is 45. And let's see. How do I turn a 6 into a 2? Let's divide by 3. So that would be 4 divided by 3. Which on a calculator is 1.33 repeating. And we'll go all the way back to our original ratio. How do I get a 3 to a 1? Which will take my 2. So 3 divided by 3. 2 divided by 3. So that gives me 2/3. Or 0.66 repeating, just because I know that. 2 divided by 3. All right, so let's look. Do 4 gallons cost $3? Nope, because 2 gallons cost $3. Does 1 gallon cost $1.50? Yes. 30 gallons cost $45? Yes. $2 will get me 30 gallons? Nope. And $1 will get me 2/3 of a gallon? Yes. Excellent. All right. Caterer. Now, some of you might not know what a caterer. They're the people that make the food for an event, like a wedding or an anniversary or a big party, something like that. They want 21 pounds of pasta. The store sells 8 pounds of pasta for $12. How much will the caterer pay? Well, what is our ratio? Our ratio is 8 pounds pasta to $12, or 8 to 12. Would it be more helpful to write an equivalent ratio with 1 as one of the numbers? Yes. If I'm trying to make a 21, 8 is not friendly with 21, and 12 is not friendly with 21. But would I rather have it be 1 pound of pasta or $1? So explain your reasoning. So I have pasta and money, and I have 8 to 12. If I'm going to go to the store, it is easier to buy pasta by the pound, 1 pound, 2 pound, 3 pounds, than it is to buy like 0.333 of a pound, right? Money is usually in your decimals. Food is usually not. So I would say let's make this into, if I want to just go straight to a 1, how do I turn a 1 and 8 into a 1? Well, I either say times by 1/8 or I divide by 8, right? So I could grab my calculator because that would look like 12 divided by 8. 12 divided by 8 equals, so for every 1 pound is $1.50, which we could easily figure out then how much 21 pounds would be, because we would just multiply times 21, multiply by 21, and that would be $31. Now it says 31.5, but American money has 2 places for change. I really want you to be in the habit of making sure to put in that 0. So it's really $31.50. All right, lesson 15. Lesson 15, we start another type of diagram. This is called the tape diagram. All of the parts of the tape diagram are the same size, so be careful when you're drawing. You want to try to make them the same size and think of them as being the same size, and they have the same value. That means each box is worth the same amount. For example, this tape diagram represents a ratio of ducks to swans in the pond. So how many ducks, how many swans? So it's a 4-to-5 ratio. First part has 4 parts, second has 5 parts. There are a total of 9 parts in all. If we know there are 18 birds in the pond, we can figure out that each box represents 2. You take your total of 18, divide by the number of boxes, and that tells you the number that goes in each box. So 2. So for example, if there's 4 boxes of ducks and each box is a 2, 4 times 2 is 8. If there's 8 ducks in the pond, how many are swans? I could think 18 minus 8 equals 10, or I could think 5 times 2 equals 10. Either which way, there's 10. How does changing the value of each part of the tape affect the total amount? Think of it as repeated addition. So if we change the value of each box, we have to multiply. Multiply that number by the number of boxes. That means multiply the number of boxes. All right, let's practice what we're talking about. Here is our ratio of red paint to yellow paint, making orange. What is our ratio? Well, how many yellows, how many reds? 2 yellows to 3 reds, because it's always important the order of the words. How many total cups of orange paint? 1, 2, 3, 1, 2, 3, 4, 5. So we have a total of 5 boxes. You could do 5 times 3 is 15. 15 cups. You could skip out by 3s, 3, 6, 9, 12, 15, or you could say there's 9 red and there's 6 yellow for a total of 15. Several ways to do that. At the kennel, the ratio of cats is 4, dogs is 5. If there's 27 animals in all, here's the tape diagram for the ratio. What is the value of the rectangles? Well, how many rectangles do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have a total, that's a bad swoosh. Should be like that. We have a total of 9. And we know it has to equal 27. So that would be my 27 divided by my 9 boxes. Tells me how many in each box. And of course, you can use your calculator. 27 divided by 9 equals 3. How many dogs are at the kennel? 3 times 5 is 15. And how many cats? 3 times 4 equals 12. And the last page. This is a summary of kind of all the different styles for solving ratio problems. This first one, which was actually the last one we did, we have adults to kids is 2 to 7. We can use a tape diagram. Because both parts of the ratio have the same unit, so people and people, and it tells us all the parts. 1, 2, 3, 4, 5, 6, 7, 8, 9 total boxes for 180 people. So it's 180 people divided by 9 boxes. Tells you the number to go in each box. So that's where they get the 20 from. Here, two parts of the tape diagram represent adults. There are 40 adults in the school. 2 times 20 is 40. This tape diagram has, what do we say, 9 equal parts, and they represent 180 people total. And that's how they got the 20. You can use double or triple number lines. They're useful when you want to see how far apart the numbers are from one another. They're harder to use with very big or very small numbers, because if I want to go to 180, I would be, this is counting by 9s, that's like 10 more times. My paper would have to be really long, right? It's way out there, way out there. So if I have big or really small numbers, it's useful to use a table. I like a table because we can skip around to whatever we need to know. 9 times what is 180? That's where we can do that division problem. You say 9 times blank is 180. If we think of our fact families, that means 180 divided by 9 equals blank, which is where we got the 20. Then 2 times 20 would be 40. And we could also figure out the kids. It would be 7 times 20, which would be 140. All right. Another reason that we use diagrams is to help communicate our thinking to others. And I do say this to you as I walk around. I'm like, how did you get this answer? And quite often kids say, I don't know, I just typed some stuff in my calculator. Well, that's not good. You need to make some good habits, right? You need to label your diagram so we know what it represents. Label important amounts. Make sure you read what the question is asking And make sure when you're done that you actually answered it. Sometimes we do a lot of great math, but we don't necessarily answer the question. Make sure your answer is easy to find. If you circle it some way that somebody can see it, include your units, right? 4 cups instead of just 4. I'm not really great at forcing you to do that. That's something you need to work on yourself. And then double check that your ratio language is correct and matches your diagram. In lesson 13, one of the tables was incorrectly done. So the 3,000 did not match the diagram. All right, couple more problems to practice. This is a challenging problem. We have nickels, dimes, quarters. We have 2 nickels for 3 dimes, 2 dimes for 5 quarters, and then we have a total. I'm going to make a table, but you could also make a double number line. So I have 1, 2, 3, 4 things in my table. I have nickels, dimes, quarters, and total. And I'm going to think about this. I have 2 nickels for 3 dimes, 2 dimes for 5 quarters. So 2 nickels, 3 dimes. Oh, I did it wrong. Just because I like things to be in order. 2 dimes for 5 quarters. And then I have 2 nickels for 3 dimes. And I know my total is going to be 500 at some point. So the only place I really can work on a relationship, for me, I could either go this way or I could go this way. I could do lots of things. I'm going to go this way. What do I do to a 2 to make it a 3? Right? So it's times mystery number, which means I have to do the opposite, which is division, right? 2 times a mystery number equals 3. So we think of it like this. So using my fact family, I would have 3 divided by 2 equals my mystery number. What is 3 divided by 2? So that's 1.5. So 2 times, I wish I had a different color this whole time. So that's 2 times 1.5. So if I want to find this number, I could do 5 times 1.5. And that gives me 7.5. And I don't really want to have decimals. I want to have a whole number. So I think I'm just going to take all that information and I'm going to double it. So everything times 2. Which gives me 4, 6, if you're not sure, 7.5 times 2 is 15. And then let's see where our total is at this point. 4 plus 6 is a 10. 10 plus 15 is 25. And I need to get to 500. I'm going to double it one more time because I think 50 would go nicely with 500. I know 25 doubled is 50. Double 15, double 6, double 4. And then I'm just going to double check my math. 8 plus 12 is 20. 20 plus 30 is 50. Okay, let's put my 500 down here now. Can I easily get to 500? Yeah, times 10. Now, I never went back and found that number. It doesn't matter because I'm really trying to get to the 500. I didn't do that number because it was messy. It was a weird decimal. It was like 1.333. So that's 300, 120, and 80. And hopefully you notice when you multiply by 10, it really just looks like a 0 at the end of your number. So if we did it correctly, these numbers added together will equal 500. Which it should, because all we did was change a 0. 0, 2 plus 8 is 10, 3, 4, 5. Right on. Good job. You guys are done. Awesome job. Trying to find my mouse. Trying to find my mouse.